Good afternoon, everybody. Welcome to class today. Thank you for joining me. Whether you're watching live or you're watching the recording, I appreciate you watching. Thank you for joining me today for this afternoon's live class. So today we're covering Module 2 material. Last week we had our pre-recorded video that covered Module 1 material. Module 1 is more about just general, kind of thinking like a programmer, dipping your toe into, writing code. And here in Module 2, we're going to talk more about some of the actual parts of the Java programming language that will allow us to actually do some development. So today we're going to talk about variables. And in the process, we're also going to talk about objects. So we're going to introduce the concept of an object today as well. So we're going to talk about variables, which is putting data into buckets, right? And so I always kind of explain this, a variable as a container, right? So when we look at a variable, what we see or what we should see is sort of a container, right? I have this sort of box. On this box, I can put a label. And on the label, I put a name. And that name is descriptive of the type of data that's being held in this box, right? So when we think of a name for our variable, we oftentimes want this name to be somehow related to the data that's going to be inside of our container, because when we're working with this, we want it to kind of make sense to us as we're working with it, right? So if we have to go kind of back and forth between different things and, maybe we take a break from our code and we go back to it later, we want things to make sense to us. So when we're coming up with names for our variables, we want to kind of at least have them to some degree be similar to what's inside of that variable. So then when we refer to the bucket, we're referring to the name on the bucket and not the data within, right? We call this a symbolic relationship, because the name that's on the bucket or on the container has a relationship to the data that's inside of that container. So that container can change, so that data, I should say, so the data in that container can change, it can update, it can become something different, right? We can manipulate that data, but we can still refer to it by its name. And that's still going to refer to the same location in memory, which is that variable bucket. And so when we create a variable, there are six properties that are associated with a variable. For now, we're going to concern ourselves with the first three. Later on, we will concern ourselves with the fourth. And really, those are going to be the only four of the properties that we're going to kind of concern ourselves with this semester. So for the time being, we're only going to concern ourselves with the first three. And we'll kind of dabble a little bit with the fourth when we talk about objects. So when we're creating a variable in Java, we need to know the name of that variable, right? So we need to have a variable name. We need to know what data type that variable is, right? And there's a good video that I made in your module that goes into the primitive data types and what they are and what the different types of our variables are in general, right? So there's a good video on that in your module, so I'm not going to go into that at the moment, just to save us a little bit of time. And then the value, that's the value that you're putting in that container. So the first thing that we're going to concern ourselves with is naming the variable. And so when we're naming a variable has specific rules, right? The first one is that a variable must begin with either a letter, an underscore, or a $sign. We cannot begin a variable name with a number. Remember that when your computer sees a number, it thinks it's ready to do math, right? So in this case, we want to make sure that we're not starting our variables with numbers, because if our computer sees that, it's going to think math time, and then it's not going to get to do math, and it's going to get mad at you, right? The next thing is that after the first letter, then you can include numbers, right? Because then it knows, okay, this isn't math, this is something else, right? So after that first letter or that first underscore or that first $sign, then I can include a number and be okay, right? No spaces are allowed, no special characters are allowed outside of an underscore and a $sign in the beginning. A variable name can be any length, but we like to try to keep it short. And they are case sensitive. And so that kind of ties back into the stuff that we were talking about in the live class last week, or the pre-recorded class last week, with the idea that uppercase letters and lowercase letters are different, so they mean different things in context to my computer. So we want to make sure that we're consistent when using casing, uppercase, lowercase, in our variables. We also want to make sure we're not using Java keywords. And you might think, well, what is a Java keyword? And a Java keyword, or keywords in any programming language, are words that are already reserved with a specific purpose inside of the programming language. So I have a list of them here on this slide. Right, we see things like abstract, assert, boolean, break, byte, case, catch, char, class, const, continue, default, do, double, else, enum, extends, final, finally, float, for, go to, if, implements, and so on and so forth, right? Pause here and read all these if you need to. All right, these are words that you cannot use because they already have a purpose. They're already reserved for a specific purpose in Java, right? So we can't use them for anything else. So just as a little test based on those rules, there I have these variable names here for you. So especially if you're watching the recording, which it doesn't look like anybody is in here with me live right now, so that's fine. I want you to try to test yourselves on these 6 variable names. Some of these are valid variable names. Others are invalid variable names. So especially if you're watching the recording, pause the video here and try to test yourself to see which of these you think will work and which of these will not work. I'll kind of hold just a minute to give you all some time. Pause the video, answer these, write them down on a little sheet of paper that's next to you. I'll be revealing the answers in 3, 2, 1. So these are the answers. The first one will work. It's just a word, right? It starts with an uppercase letter, but that's fine. It's just the word grade. The second one will not work. Remember that we cannot have any special characters besides an underscore inside of our word or inside of our variable name. So those parentheses are not going to work. The third one will work. The only special character we can have is an underscore. So that one will work. The fourth one will not work. It starts with a number. The fifth one will not work. It uses a reserved Java keyword, which is default. And the final one will work. You can start a Java variable with a $sign. So we kind of understand variable names, variable types. We could talk about declaring a variable. And so when we're declaring a variable, we are just essentially establishing a container in memory. Right? So we can head over to a Code.hs window now and start a new sandbox program here. Remember that we're going to be in Java main. And we can declare a variable. And declaring a variable just uses a data type and a name for a variable. So if we have, say, an integer variable, we can use int as our data type and the name variable name, or whatever useful variable name that you can think of for your specific application. Right? Now this is variable declaration. And so what I've done here, right, is I've taken that container that I talked about and I made it in memory. So now there's a container in memory that's ready to contain an integer, right? And so this is a standard int, so it's a 32-bit signed integer. The primitives video in the module talks all about that. So we basically reserved 4 bytes of memory here for a number, a whole number that we can put in here. Now there's no data value in here yet, right? All we've done is we've declared the variable. And we can do this with, any type of variable we want, right? We can have an integer, we can have a double. We can have a string, although a string is a little bit different. Note that, even when we write out a string declaration here, that the word string there looks different. It starts with an uppercase letter. One of the things that we said last week in that video is that when we see an uppercase letter, that's typically indicative that it is part of a class. So that means it's part of an object. Right, so we use a string object to do this. But we could even take something like a Boolean. And now we've created containers in memory for each of these things. Now they don't have values in them yet. In order to give them values, I would have to set the name of that variable equal to some value. Like so, right? So we see string again looks a little bit different here, right? Because again, string is an object, it's not a primitive. So it works differently. We have to create a new string object in order to do that right, which creates a new instance of that in memory for us to be able to use. But now I can take any one of these items and I can print it out. And it's going to print out the value that is associated with that name in my console. We should get 27, which is what we got. Right now, if that value changes, then what's going to print out is going to be the most recent assignment of that variable prior to that print statement. Right? So if I press the run button now, it's going to tell me that variable name equals 13. So we can run this. You can see that variable name equals 13. Now if I put system.out.print line variable name here, remember the flow of execution of our program, right? Our program goes from top to bottom, left to right. And so at this point, when this runs, the variable name is 27. But at the point when our second print statement here runs, variable name is 13. Right? So what I should expect in my output now is 27, 13. Which is exactly what we get. And so we call this reassignment. When we take the value of one variable and change it to a completely different value. Right, and so another key thing to remember here, right, is whatever this variable name is, it's not directly tied to the value that's inside the container that has that label on it. It's basically just like a label that's on that container, right? So think about, Christmas was a couple weeks ago. Maybe at the start of the month, you put your Christmas decorations up, or maybe you knew somebody who had Christmas decorations that, put them away at the end of the month. And, when you go get that box to put the Christmas decorations in it, it probably has a label on it, right? It says Christmas, or it says decorations, or it says something on it, right? That's relevant to what is inside the box. And then you go and you get that thing and you take it out and you use it. And then you put it back away and put it back in storage. And that's essentially what's happening here with the data that's inside of these variables. When the variable name is called, we go get that box that has that data in it. We pull it out. We take the data out of that variable, we use it, and then we put it back in and we put it back. And so if we go take that box out and we take out the Christmas decorations and we put in old shoes or whatever, and then we put it back, then when we go pull it out the next time, it'll have old shoes in it. And not our Christmas decorations, right? Like our Christmas decorations won't magically reappear. So when we're looking at something like this, it's important for us to understand that. Now, this is one way that this could be done, right, with declaring and assigning your variables separately. You can also do this in a singular statement. So I could say something like int new integer equals 32. Right, so I've done all of that in one variable now. And so now I can print out new integer. And it's going to just print out 32. Now, one thing I cannot do, right, is once I've established a container, I can't try to reestablish that container, right? Like I can't put int variable name equals 45. That does not work. That'll break. This will break my program. Remember that when I put int in the name of my variable, that's what's establishing a container in memory. So it's made this box and it's put it in memory. And now I'm telling it to make a box again that already exists and put it in memory again. And I'm basically creating a paradox for my program, right? Because I'm trying to tell it that this thing in memory is simultaneously 13 and 45, which doesn't work very well, right? Like this is going to break my program if I try to run it. We'll see it break my program because this container already exists. I already made it up here. I can't make it again. If I wanted to reassign it, remember, I just leave the data type off. Or if I want a new variable, I need to create an entirely new name to create an entirely new container. Right? These are super important things. And I can use these to do math with one another, right? Or do whatever. Right? Remember that the names of these variables are just symbolic of what's inside of them. So basically anything that I can do with the value that is inside of that variable, I can also do with that variable name. So if I wanted to say, create a new variable, and set that equal to the results of new integer plus variable name, right? It's going to see new integer here. It's going to say, oh yeah, I know that thing. I'm going to go get that box. I'm going to take the data out of that box. I'm going to put it here. I'm going to use it. And then I'm also going to add it to this other variable name. So I'm going to go get that box, pull it out, use that. Add those two values together and put the result in this new box that's going to contain the results of these two numbers being added together. And so new integer is 32. The last instance of variable name is 13. So we should expect this to be 45. So if we were to print this out, system.out.println new variable 3 is the last one in our list there over on the right. So it is 45. Right, so anything that we can do with any of the values inside of these variables, we can do with anything else. Or with our variable names. So we can use them to do some calculations. Now, let's change things up just a little bit here and talk about a different way we can kind of use variables. And that's by using variables as objects. Objects. And so this is where we're going to spend the bulk of our time today, is with objects. So Java is an object-oriented language. And so when we're writing Java and we're writing good Java, we should probably look at objects in order to really discuss working, functional, good Java. Now, most of what you'll see in the modules does not include objects. Right? It's just standard, what we call functional Java programming. There are basically two ways that you can write most programming languages. You can write them functionally, which is using methods or functions to compose programs to do things that way. Or you can write things object-oriented. And so you're familiar with writing things object-oriented. In a lot of these live classes, we'll show you object-oriented methods or object-oriented approaches so that you'll know what you're looking at. And if these make more sense to you, then I encourage you to use them. Although with where a lot of people are at when they're taking this class may be some people's first approach to programming anything. And if it is your first approach to programming anything, programming with objects can seem confusing. Because it seems like we're doing extra steps to do some stuff that probably doesn't seem like it needs to be done, but it's important because it is more efficient in memory. It uses memory better. It's a little bit more flexible in terms of how we can use our programs modularly. Right? So, what is an object? An object is a component of a program that knows how to perform certain actions and how to interact with other elements of a program. Now, that's sort of a bad definition, right? Like it's a technically correct definition, but it's a bad definition, right? Because it's kind of obtuse, it's kind of abstract. It really doesn't do a great job telling us, why we would use an object or what an object really is. So the way I usually like to explain it would be our second bullet point here. You're an object. I'm an object. We are all objects, programming-wise. We belong to class person. And as different people belonging to class person, we have different identities, we have different attributes, and we have stuff that we can do. We have methods. Right? So we all have different identities, we all have different names, we all have different attributes. We all have different hair color, eye color, skin color, height, weight, all these different attributes that are different. We're still people, right? We're still objects of the person class. We're all still persons. But we have different attributes, we have different identities, but we can do different stuff, right? We can have different things that we can perform. So an identity gives a unique name to an object and enables one object to interact with other objects. Right? So essentially what happens when I give an object an identity is I'm creating an instance of that object in memory. I am birthing my person. So now my person is born, it exists in the world, and it is ready for everything else. That person is represented by attributes that make it unique, that reflect properties of that person. Right? Those are our attributes, right? They're values, they are identifiers, they are things that make that object unique. So this gets into the idea of, like, for a person example, it's eye color, hair color, whatever, right? Your unique identifying characteristics. So I create a person, I give it a name. That person has special attributes that make them different from other people. But then it also has things that it can perform. It's represented by methods of an object. And when we get to talking about methods in future modules, modules 4 or 5, then we can include those to do a little bit more with our objects. So here again kind of breaks that down, right? Like, identity is the name of the person. The attributes are going to be things like hair color, eye color, age, things that are unique to that individual. Methods being things that person can do, things like walk and talk and eat, things that allow it to interact with the world around it. And so we say that an object is part of a class. And so what is a class? A class is a user-defined blueprint or prototype from which objects are created. And so when I create a Java file, I create a class. And this might be something that you've noticed. Right? For example, like if I look at our program here that we were just writing, we look at the tippy top of our program here, and we see my program. My here starts with an uppercase letter. When we see an uppercase letter at the beginning of the word, we usually know that that's indicative of a class. And so right before that, my program, we see the word class. This is a class. And so we can think about a Java file, right, as a class. And so if I create a new file, let's call it person.java. Notice that I put person with an uppercase P. We see as I create my new file, it creates my public class for me. And my file. So I'm going to change this to be my main file here so I can run this file with the run button. So we can see, right, like if you're in CodeHS, if you click this little drop down by your file name, It'll allow you to change something to the main file. That's what allows it to run with the run button. So public class person. Now, in public class person, I can create variables at the class level. So this is scope, right? So I might create a string hair color variable. I might create an integer age variable. I might create a string eye color variable. Right, and so what we've done here with our variables is we've declared them above our main method. We call this instantiation, or we say we've created, or actually this is initialization. Instantiation comes later. So we've initialized these variables that we're going to use as part of our object. And where we put the values of the variables are inside of what we call a constructor. So our constructor has the same name as our class. In this case, uppercase P, person. Open close parentheses right after it. And then we add our curly braces. And here is where we'd put the values of these variables. We'd say this dot hair color equals brown. This dot eye color equals green. This dot age equals 25. Right, so now we've given static values to our object. And so if we were to create a new object of this person constructor, maybe say this person's name is Dave, we could say person Dave is a new person. And now we can system.out.println Dave.age. And that will give us the age of the Dave object. So it should just tell us that Dave is 25, because that's the static value we have encoded in our constructor. Now, this isn't particularly useful, right? Because that means every person that we created of every object, or every object that we created of our person class here, would have the same hair color, have the same eye color, have the same age, right? If I created another person Susan equals new person, right? Since our values here are static, that means that Susan's age and Dave's age are the same, which they're probably not, right? Like, not every person has the same age, not every person has the same eye color, hair color. So we need a way to get different values into these constructors. And that's where our parameters come along. Right? So instead of using static values like this, I'm going to create myself some variables here. And I'm going to see string HC, string EC, int A. Right, so now I can change this to, instead of being equal to brown, green, and age, I can change them to be equal to these variable names that are in here as our parameter, HC, EC, and A. So now when I create a new person, when I instantiate a new person, when I create a new instance of my person object here, I can define them with different personality or with different traits, with different attributes is the word that we're using, inside of these parentheses that will map to these variables. So I might say Brown green 25, but then Susan might have black hair, brown eyes, and maybe she's 47 years old. Right, so now we have two completely unique people in memory. Right, we've given them an identity, we've given them a name. This, in this case, their name is their identity. So whatever we put here is their identity. We've given them attributes. Whatever we put in here that maps to here are their attributes. And then later on, when we add methods, we can start talking about how we can give them methods. So now if I printed out Dave's age, Dave.age, Dave.age, and Susan.age, these are now two different values. They're now 25 and 47. Now this gets incrementally more useful when we start to bring methods into this. Right, because like one thing that I might do is I might not have age on here, right? Or age might be something different. I might have something like int birth year. I could also create an int this year. Right, and so there are some little considerations that we'd want to have for this, right? Because you're basically, like, your birthday would have to be today or earlier in the year for this to be accurate. But, instead I might take this and say, oh, well, this is going to be, instead of age, this is going to be birth year. So we could say this dot birth year equals BY. Then this dot age. And we could say this dot this year is 2025. So now we can say that age is this dot this year minus this dot birth year. So we're able to get an additional piece of data out of this that we would not have been able to get otherwise. Now we can say something like so now we put the ages there because we put the birth year there as our third piece because that's our third parameter there. And we get 25 and 48 because math, right? Remember that it's not exact, right? Because we would need a little bit more to be able to determine whether the birthday was before today or after today, right? This is a really quick example that we're doing here. This is just to demonstrate how we could use different values to get different things. And they're going to be different for each person in our object. And so when we take this a step further, right, one of the interesting things that we can do is, right, when we get to the array module, we'll talk more about that. We can create an array of these objects. Right? One of the things that we want to do is we want to make sure we spell it correctly. We can create an array of these objects. And then loop over these objects. To address each individual object. Whoops. What did we forget? Oh. That's what happens when I try to do multiple programming languages at one time. That should be curly braces and not square brackets. There. This person has brown colored hair. This person has black colored hair, right? We're going through each of those objects. They're their own people in memory, right? And we can find and we can loop over them and we can grab different things out of them. And like this stuff will be, right? This is an array here. So this will be for the future module when we get to arrays. This here is, this is a loop, so this will get us to 4 loops, which both of those are in later on modules, so you don't have to worry about those right now, right? But, you know, I'm just trying to show you like how we can kind of expand this and do more with it. And we'll get more practice with this as we kind of go forward, right? And in a lot of these live classes or the ones that I'm able to do live with you, I'll try to write with objects as much as possible so you can see a combination of the functional style programming, which is what you get in the modules as you're reading through your material there, and the object-oriented programming, which would be what we get in things like this. And so at the top here, I will just put that this is our object-oriented example. And I'll send you all out this file as well when I send you the recording today. And so those are the big points that I want to talk about to you all today. Let me look through my notes here really quickly just to make sure there's nothing else that I want to discuss. And I think we're good. So we'll leave it at that. Doesn't seem to be anybody here with me live today. So if you're watching the recording and you have any questions, please send me an email or a Teams message with your questions. With that, that's all that I have for you for today. Thank you for watching, and we'll see you next time.